Math 3 SBAC review for exponents, rational and irrational numbers. So first of all, just to recall what you may or may not remember, rational numbers are a number that can be written as a ratio. A ratio is a fraction, which both the numerator, top number, and the denominator, bottom number, are whole numbers. So the number 8 is a rational number because it can be written as 8 over 1. And you can see over here to the left, here we have rational numbers. So all of the numbers in here are examples of rational numbers, okay? Now, an irrational number is a real number that cannot be written as a simple fraction. Irrational means not rational. So the square root of 8, that, if you simplify it, it could become 2 root 2, but you still have a root. Roots, and if you type like the square root of 2 into your calculator, it will be a decimal that doesn't repeat, and those are irrational numbers. In order to write a decimal as a fraction, it either needs to repeat or end. So these are examples of irrational numbers. Pi is also an irrational number. This root on this side, the reason why this has a root is this can actually be simplified to be 4/3. And so there's no root in that answer. Same thing here. The square root of 9 is actually 3. And so it is no longer a root. So irrational numbers end up having a root in the answer that can't be simplified, or numbers such as pi or decimals that don't repeat. Okay. There are a couple videos here that as we're going through this or as you're doing your homework, if you are still not getting things, I highly recommend going and watching these videos. This one, approximately 4 minutes. This is about 2 minutes, so they're not very long, and you can go and watch them. If you go to Google Classroom, you can click on the links within the PowerPoint presentation and it'll take you right there. So we're going to start doing some examples. This first one, it says, choose 2 different numbers whose sum when added would be irrational. So what does irrational mean? Irrational means that it can't be written as a fraction, okay? That you would end up having a decimal that doesn't repeat and that kind of stuff. So since we want it to be irrational, I need either 2 and root 2 or root 8, because even if you simplify this, this will be 2 root 2. You would need to have one of these with your answer. So there are lots of different answers that you could possibly choose for this. -7 plus 2 root 2 is a possible answer. If you were to add those, it's going to be an irrational number because you have a root with your answer. 2 root 2 plus 2/3, 2 root 2 plus 1/5. All of those would be examples. Additionally, you could use the root 8. So you could have -7 plus root 8. 2 root 3, or sorry, 2/3 plus root 8, 1/5 plus root 8. Also, 2 root 2 and root 8, if you add those together, those will also be irrational because they would end up adding to be 4 root 2, which is also irrational. Okay. This next one says choose 2 different numbers whose product when multiplied would be irrational. So you have to be careful on this one. Again, in order for it to be irrational, you need to have a root in your answer. And so some possible answers. Oh, also you need to remember that product means multiplication. And so 2 numbers multiplying and you still have a root left over. So -7 times 2 root 2, that equals -14 root 2. So that would be an example of 2 numbers whose product when multiplied give an irrational answer. If you took 2 root 2 times root 8, that would end up making a rational number because this would be 2 root 16, and we know that 16 makes 4 and 4, or breaks down to 4 and 4. And so you'd end up with 2 times 4, which equals 8. And so you couldn't choose those 2 because it would actually, when they're multiplied, make a rational number. Two fractions multiplied together will not give you a root. You'll still have a fraction. That would be rational. That wouldn't work. But you could do 2 root 2 times 2/3. That would make an irrational answer. 2 root 2 times 1/5. That will make an irrational answer. And then the same thing with the root 8. You can multiply it to -7. You can multiply with the 2/3 and the 1/5. All of those would make irrational answers. Okay. Next question. Select the appropriate box to identify each expression as having a rational or irrational sum. So if we add these together, are we still going to have a root in the answer? Your answer should be yes. And if there is still a root in the answer, it is irrational. Okay, on this next one, the square root of 9 plus 13. Well, first of all, the square root of 9 can be simplified to make 3. So this is really 3 plus 13, which equals 16. Okay, can you write 16 as a fraction? Your answer should be yes. 16 can be written as 16 over 1. It is a fraction, which means it is rational. 9.4 plus -11. If you add those together, you end up getting, let's see here, -1.6. And -1.6, it's a terminating decimal. This goes out to the tenths place. So if I was writing this as a fraction, it would be -16 over 10. And you could reduce it and stuff, but because I can write a terminating decimal as a fraction, it is rational. The actual answer here and this stuff doesn't matter. It's that we know since this is a terminating decimal, it can be written as a fraction. And then here I would still end up with a root in my answer, so this is irrational. And again, this was asking about sums. On this next one, it's asking about product. So here, if you notice, we're now dealing with multiplication. So again, if I multiply these, I'm still going to end up with a root. I would end up with 5 root 3 over 3, and so therefore it is irrational. Here, the square root of 9 is 3, and 3 times 13 will give me 39, which is an rational answer. 9.4 times -11, it doesn't really matter what the answer is there. It will be able to be written as a ratio of 2 numbers or a fraction, and so that would be a rational. And then -4/3 times -5 root 5 will still have a root in this answer, so therefore it will be irrational. State a number that will produce a rational number when multiplied by 5/3. So we're taking 5/3 and I want to multiply it by something in order for it to give me a rational number. So rational number means I will no longer have a root. So I want to give you just a little bit of time to think about if you could give me an idea of what would be an answer that we could put here. What could I multiply this by in order to make a rational number? Okay, so your answer should have some sort of root 3 in it because I need root 3 in order to make, a root 3 in order to make a pair of 3's, which then makes 3. Because root 3 times root 3 is root 9, which is 3. And so 3 times 5 ends up giving me an answer of 15. So one possible answer is root 3. You could have chosen something like 2 root 3. That would also work. All it would be is that when you got your pair of 3's, you would be multiplying 5 times 3 times this 2 as well, and so this would make a 30, but again, that 30 is a rational number. So another example of an answer could be 2 root 3. You could have also done something like root 27, because the square root of 27 will end up breaking down, and with this other root 3, if you go root 3 times root 27, you get root 81, which makes a 9, and 5 times 9 would make 45. So root 27 is another example. So again, in order for it to be a rational number, we want to eliminate the roots, and so 5/3 just has to be multiplied by some form of root 3 in order to make it a rational number. This next one says, state a number that will produce an irrational number when multiplied by 5/3. So on the previous one, we wanted to make a rational number, and now I want to write or make an irrational number. So again, there are a lot of different answers, but we're taking 5/3 times something, and we want it to be irrational. In order for something to be irrational, we need to end up with a root in our answer. And so basically, any number would work. You know, we could put 2 here. 5 times 2 makes 10√3. That's an irrational number. Any number here would work if it doesn't have a root. Okay? So I'm just going to say 2 is my answer for right now. But again, it could be any number that you plug in there. You just want to make sure that you have a root that doesn't simplify in your answer once you finish. You could also even do something like root, let's say the square root of 2, because the square root of 2 and the square root of 3, those wouldn't simplify, and so you'd end up with 5√6. So root 2 is another possible answer that you could have. That's going to still make it irrational because we still have a root in our answer. Okay, this next part, I just want to quickly review exponents and some of their rules. And so this is one rule right here. We know that if we have a root, the power goes to the top, or the exponent here goes to the top, and the root goes to the bottom, and you have a fractional exponent. And so this one right here, if I were to change it to exponential form from root form, it'd be x. This number right here is the power, it goes on top, and the root is 5. So x to the 3/5 power is the same as the 5th root of x to the 3rd. This next one is that if you have two things multiplying that have the same base, and in this case the base is p, you can add the exponents. So here both of these have a base of a, so I can add the exponents, and so we have a to the 4 plus 3, which is a to the 7th power. This next one is division. Same thing, if you have the same or like bases and you're dividing, you can subtract exponents. And so here I would have y to the 7 minus 9, which makes y to the -2nd power. Normally we won't have negative exponents in answers, and so we'd end up moving this to the bottom, and I end up with 1 over y to the 2nd. Another way that I think about this sometimes is that these I know will subtract, and then it stays on the side of the larger exponent. Remember that you can also think about there's 7 y's here, there's 9 y's here. They cancel out 1 for 1 all the way through. 7 of them cancel out, but you still have 2 left on the bottom or the denominator. This last one, again, if you have 2 square roots, you could change both of these to exponential form. So p to the r over q times p to the s over t. And we have like bases again, so I can add the exponents. Okay, so here this is x to the 3/2, because if you have a square root, if it doesn't stay what it is, it's a 2. Okay, and this is saying times x to the 2/5. So that means I can write this as x to the 3 over 2 plus 2 over 5. Well, in this case, I could still add these, but in order to add them, you need common denominators. And so the common denominator between 2 and 5 would be 10. And so since 2 times 5 makes 10, 3 times 5 makes 15. 5 times 2 is 10, 2 times 2 is 4. And so this ends up being 19 over 10. And I can divide by 2 and reduce those, and I get 8 over 5. And so x to the 8/5 power is another option for this. Okay. So this next part says, determine whether each expression is equivalent to 2x to the third raised to the 2/5 powers. So what you have to be careful about on these is that you understand how to simplify this correctly. So I'm going to write this over here to the side, 2x to the third to the 2/5 power. This 2/5 power goes to both the 2 and to the x to the third because it's in parentheses and it's touching the parentheses, which means it goes to everything inside the parentheses. So this is 2 to the 2/5 power, and you can think of it as being times x to the third times 2/5, because powers to powers multiply. And this is really 2 to the first, so it's like 1 times 2 to the 5th, which will just be 2/5. 1 times 2/5, which is 2/5. Okay. So right here I have 2 to the 2/5 and x to the 6/5. If we wanted to rewrite this, since they both have this 5th root, this is really the 5th root of 2 to the 2nd power and x to the 6th power, because the bottom number is the root and the top number is the exponent. And we could simplify that, and that is 2 squared is 4, and this is still x to the 6th. So let's go through and look here to see if we can tell things. So 5th root of 4x to the 6th, that matches. So we're going to say this one is yes. This next one, they have an x pulled out in front. So if we look here, this is x to the 6th, and this is a 5th root. How many x's would we need in order to bring out a group? We would need 5. This is x to the 5th and x. So I have one group and one left over. So that means I would end up with x and then the 5th root of 4x left over. So if we look here, do these look the same? And they look similar, but this is missing what? It's missing an x, so this answer is no. Okay? Here, they just have it as 2, but we know this is either going to be a 4 or a 2 squared. So this is missing a square, so that is also a no. This one says x and the 5th root of 4x, which it does match here, so that is a yes. And here, this is a 5th root of 4x to the third, but we know it's a 5th root of 4x to the 6th, and so that one is a no. Here we go. Simplify the expression and write the answer in exponential and root form. So we're going to first start by changing these both to exponential form, and that's going to make this x to the 3/4 power. Since they both have the same base of x, we can add the exponents. So you have x to the 3/2 plus 3/4. In order to add those together, though, they need to have common denominators. And so my common denominator is going to be 4. This one already is a 4, so we keep the 3 on the top. This is a 2, so in order to make it a 4, we have to multiply by 2, and whatever do to the bottom, you also do to the top. And so 3 times 2 makes 6. We add there, and we get x to the 6 plus 3 is 9/4. So this would be my answer in exponential form. To write that in root form, the 4 represents the root part, so the 4th root of x, and this your power, x to the 9th. So either of those will work. Or actually both of them are going to work since I want both answers. Next, select an expression equivalent here. So here we have 1/2 and 1/2. 1/2 times 1/2 is 1/4. These are like separate pieces. These are whole numbers in front, and then these are x's next to them. Since these both have x, we can add the exponents. And so if we add that, we have 1/5 plus 1/2. When you're adding, they need to have common denominators. So again, we're going to go x. The common denominator would be 10. And so 5 times 2 makes 10, so 1 times 2 makes 2. 2 times 5 makes 10, 1 times 5 is 5. We go ahead and add those together and we get x to the 7/10. And then I also still have that 1/4 in front. So I have this here, but when I go and look at the answers, they are written differently. Okay, and remember that these are two separate pieces. So this 7/10 is only going to the x, it's not going to the 1/4. And so to rewrite this in root form, it's 1/4 and it's the 10th root of x to the 7th power. And so if we look for that answer, first of all, if you look at 1/4, this one, the 1/4 is under the root and has to be outside, so that's eliminated. This says 1/2. This also says 1/2. So this looks like the only possible answer that will work, and it looks like it works perfectly. Okay, select an expression equivalent to this. So again, for me, when we're working with these numbers, it's easier to change some of these to exponential form, and then if we need to move it back to root form, we can. And so I would start by rewriting this to be 5, and it's the 3/4 power, plus, and this is 5 to the, I'm going to write it as 3/1 power. So if you notice here, there's only 2 terms. So in order to make it 2 terms, we have to distribute and multiply this through. Well, they all have the same bases, so we can end up multiplying them together, and when we multiply them together, we're adding exponents. So it's, for this first one, it's going to be 5 to the 3/4 plus 1/4, because when you're multiplying those, you're going to add those together. Okay? To the next term, it's base 5, and it's going to be 3/1 plus 1/4. Here, these already have like denominators, so we just add 3 plus 1, which makes 4. 5 to the 4/4. Plus, here, they don't have like denominators, so we need to make them have like denominators. So I'm just going to kind of put this to the side here. The like denominator would probably just be a 4. So this one already is a 4, so we're going to put a 1 there. And then here, 1 times 4 makes 4, so 3 times 4 is 12. And when we add that, 12 plus 1, we get 13/4. Okay, so this is what I have here. So we're going to go over here and look at the answers. So first of all, this one right here says this is 5 to the 7/4. Not the right answer. This means 5 to the 4/4, and this is 5 to the 13/4. I think B is correct, but I always like to double check everything else. This is 5 to the 4/4, and this is 5 to the 3/4, and we know it's 13/4, so that's not right. And then again, this one is 5 to the 7/4, which is not correct. So B is the correct answer. Here we need to solve for the value of x. If you notice, you have an equation, and so we need to simplify this side in order to match it up to figure out what the x is. So we want this side to end up looking like this side. In order to do that, we want to change these to exponential form. So to change this to exponential form, we have 36 to the 2/5 times 36 to the 7/5. Since these have our like bases, we can add the exponents. So we have 36 to the 2/5 plus 7/5. These already have like fractions, common denominators, so we can add 2 plus 7, which makes 9/5. And so based on this information right here, what would be the answer for x? Well, if you look at everything here, everything is the same, which means that x and 9 have to be the same. So x equals 9 for this problem. Okay, again, solving for x. Again, we want this side to be reduced to look like this and vice versa. We know that when we're dividing, we subtract exponents. And so both of these already have like bases. You always take the top minus the bottom. So I'm going to go 9/7 minus 2/x. And this is, I'm going to change this to exponential form. This is 25 to the 3/5. 3. So basically, 3 over 3, what does that reduce to? And hopefully you said 1. 3 over 3 reduces to be 1. So we want to make this side simplify so that it also would end up reducing to be 1. If you look here, 9 minus 2 is 7. And so if this denominator right here, if this was 7 and we were able to subtract like I did, I would get 7 over 7. And does that also reduce to be 1? Well, the answer is yes. 7 over 7 does reduce to be 1. This one reduced to be 1. So in order to make that happen, that x, that denominator, would have to be 7. So x does equal 7. So in all these problems, you're just trying to simplify both sides to figure out what that missing piece is going to be in order for them to balance out. Okay, and that is it for our review notes.